Alright, in this screencast we're going to look at two examples for solution stoichiometry problems. So let's get started. The first one, looking at this equation reacting calcium hydroxide with hydrochloric acid, resulting in an aqueous solution of calcium chloride and water. Question is, what mass of calcium hydroxide is needed to react with 425 milliliters of a 0.35 molar hydrochloric acid solution? Okay. Well, looking at it, my question is the mass of calcium hydroxide needed, so that's what I'm going to try to get to. And I have a volume and a concentration of a solution. Remember, a volume times a concentration in molarity, liters times moles over liters, will give me moles of hydrochloric. From those moles of hydrochloric, I can use this balanced chemical equation to relate it to calcium hydroxide, moles, and then from those moles get it to grams. So let's get started. I have 425 milliliters of hydrochloric acid solution. I have to get this to liters so that then I can use the molarity, 0.35 moles of hydrochloric in 1 liter. That gets me to moles of hydrochloric. For every 2 moles of hydrochloric, I have 1 mole of calcium hydroxide. And then in 1 mole of calcium hydroxide, using the molar mass, I can get to grams of calcium hydroxide. And finding that molar mass, I have 74.1 grams. So doing the math, 425 divided by 1,000 times 0.35 divided by 2 times 74.1 gives me 5.5 grams of calcium hydroxide needed. 2 sig figs because of that number. Alright, looking at the next example, we're going to use the same equation. How many milliliters of a 0.1 molar hydrochloric solution would be required to react completely with 0.500 grams of calcium hydroxide? Okay, I have grams of calcium hydroxide. I can get that to moles. From moles in this balanced chemical equation, I can go from calcium hydroxide to moles of hydrochloric. Remember that this molarity is really 0.100 molar hydrochloric is the same thing as writing 0.100 moles hydrochloric for every 1 liter. So if I can get to moles of hydrochloric, I can invert that and get to liters of that solution needed, and then from liters get to milliliters. So working out the problem, grams of calcium hydroxide times grams of calcium hydroxide in 1 mole of calcium hydroxide. From the previous problem, found that it was 74.1 grams per mole for calcium hydroxide. Then, using the balanced chemical equation, for every 1 mole of calcium hydroxide, I need 2 moles of hydrochloric solution, times, I know that there is 0.100 moles hydrochloric in every liter for that solution, and then in 1 liter there is 1,000 milliliters. So taking 0.5 divided by 74.1 multiplied by 2 divide by 0.1 multiplied by 1,000, I need 135 milliliters of the 0.100 molar hydrochloric acid solution. 3 sig figs because the givens in the problem has 3 sig figs.